Hey, this is Mr. Peterson. This screencast is about the periodic table. We've been talking about it for a while, and it's time to kind of like formalize some information about it. The most obvious thing about the periodic table is organized based on the number of protons that you find in an atom. And remember, each of these little squares represents an atom or an element, a pure substance. And so the periodic table is kind of organized that way. So here those two bottom strips have been put into the periodic table. Normally they're down below. So you can organize the periodic table in this kind of fashion, and you recognize that pretty easily, but sometimes you can arrange it a little bit differently. This one's kind of a circuitous one. So in the middle there is H. So this one kind of is a swirly, continuous, loopy periodic table, but again, it's organized based on the number of protons that you find in an element. So we start with hydrogen in the center there, and it kind of swipes its way around and curlicues its way through the different groups of elements. This is probably the one that we're most familiar with, and the one that I'll keep pulling out because it has so much information in it. And so we'll use these colors as we go here. Again, it's a tool to kind of make some predictions about things. So important stuff are the patterns and trends. The first most obvious one is the pattern and trend of increasing atomic number. So increasing atomic number, increasing numbers of protons in these elements. But that's the defining characteristic of an element, the number of protons, not the number of neutrons, and not the number of electrons. So those things can change. If you change the number of protons, then you're changing to a different element altogether. So here's our standard periodic table. If we go from left to right on this one, we change the number of electrons in each one of these families. So we start on the left from hydrogen, and we go over to helium, and we increase the number of electrons that we find in the outer shell of these elements. So here's hydrogen, lithium, sodium, potassium, and so on down there. So we've got that electron. It has one electron in its outer shell. So everybody in that rectangle has one electron, and that one electron in its outer shell is spinning around. We've talked about that before. So if we go to the next column, we've got two electrons in the outer shell. So again, we're looking at patterns and trends. So those electrons as they spin across here. And as you go across the periodic table, the number of electrons, in the middle, I think that's purple. In the middle, those transition metals are kind of a little bit different. We get over to B and C, so boron and carbon and nitrogen and oxygen. And we're back to 3, 4, and 5, and 6, and 7. And finally, we get to the far right with helium and neon and argon and those elements, and their electron shells are full. We'll get into that with another screencast, but just a pattern and a trend that we see in the periodic table. So here are the electrons in the outer shell. So 1 and 2, and then in the middle there it gets a little bit muddy. And that has to do with some pretty complex chemistry that we're not going to talk about. We can talk about the number of electrons in those outer shells, but you're gonna have to wait until chemistry before you jump into an understanding of that, because that's a whole nother layer of going down the periodic table, not just across. Okay, so what do we get here? We have the periodic table. And we can see some color coding that tells us all kinds of things. And we've talked about metals, nonmetals, and metalloids already a little bit. You've done some shading. But we can also see a lot of other information. Metals, nonmetals, and metalloids. But we can see where things are solid at room temperature, where things are liquid at room temperature, and where things are gas at room temperature. So by those different color codings. And also some things that are not found in nature. So where do we find those things if they're not found in nature? Well, we find them in leftover stuff from nuclear reactions. So plutonium, which is used to make nuclear weapons, the only way that plutonium occurs is when we have nuclear reactions, and it's kind of gathered from old reactors. And so plutonium is really a dangerous substance, but it's not found It's not found in nature a lot. There is plutonium out there, but not very much. Mostly the plutonium and those elements that are like technetium, the Tc, or any of those that are in white, those are not found in nature. We find those in nuclear reactors or in places where people slam elements together to try to make other elements. All right, so the periodic table tells us a lot of stuff. First of all, that atomic number, what does that tell you? It tells you the number of protons, that we have the elemental symbol, stuff we already know, the name, and then the atomic mass. There's another screencast about atomic, kind of modern atomic theory that'll get into atomic mass and atomic number and those kinds of things. So the periodic table, again, metals, metalloids, and non-metals. Now, what do those have in common? Because those are big groups. Remember, about 70% of the elements are metals. And what does that mean? Well, metals tend, again, there's a tendency. These are not absolutes. They conduct electricity. They also conduct heat. You know, if you've ever picked up, your teaspoon is probably made of steel. That conducts heat, but if you've ever picked up a teaspoon that's been in a hot cup of coffee and that teaspoon is made of silver, yikes, it can be really, really hot. So metals conduct electricity. Electrons can, pass through them, and they can also conduct heat. They tend to be solid at room temperature, except for mercury, which is a liquid. They're malleable, which means you can bend them, right? You can put them into different shapes, and we've used that for all kinds of things. And they're ductile. We can draw them into wires. So copper, the copper wires that are all over the place, aluminum wires, we can draw those into wires. I've fished in Canada for lake trout using a lead line. Yeah, you draw it into a fishing line. Crazy. Metalloids are in between the metals and non-metals. So silicon, germanium, those are really important tools for, or really important elements for electronics. Their conductivity varies, which is an interesting property. Silicon conductivity varies with temperature. So depending on if it's cold or if it's hot, that can influence its conductivity. So metalloids, some of them conduct electricity, some of them don't. They're kind of in between. And then the nonmetals are typically the opposite of metals. They don't conduct heat. So on the right-hand side of the periodic table, oxygen and fluorine and chlorine and helium and neon, those guys don't conduct. They don't conduct electricity. They have low boiling points. As a matter of fact, at room temperature, a lot of those things are gases, right? Oxygen, it's a non-metal. Nitrogen, 80% of the atmosphere is made of nitrogen. Carbon dioxide, carbon is a non-metal, and that's what we're made of. They're solid at room temperature, but they tend to be brittle, and some are unreactive. So on the right-hand side, all the way to the right, those noble gases are not reactive at all, or hardly reactive. We'll just say, people can't say at all, but they don't like to react because they have a full outer shell of electrons, and that'll be in another screencast to watch. So the periodic table, lots of patterns and trends here. So think about some of the patterns and trends we talked about: metals, nonmetals, electrons, protons, and we'll get into atomic mass and those kinds of things in another screencast about atoms in general. So, periodic table, patterns and trends. Hope that helps.